I have a sequence of numbers here, 3, 5, 7, 9, 11, 13. And I'm asking about the 356th term in this sequence. So I could write out the first 356 terms of this sequence and get the number that way, but we all have better things to do than spend our time with that. So there must be a way to build a model for this type of sequence in order to be able to calculate that instead of having to manually write it out. Especially when we get to question B here, what term is 25,371? I can tell this is going to be a member of this sequence because this is just all the odd numbers, and this is an odd number. But I would have to write this sequence out all the way to 25,371 and then count them up to figure out what term that is, and I don't want to do that. So how are we going to generate a formula here? Well, let's try term 1 here. Term 1 in this particular question is a 3. Term 2 is 5. Now, how did we get here? Well, 5 is just 3 plus 2. So I have the first number in the sequence showing up in my second term. I'm going to look at term 3 here. Term 3 is 7. Now if I try and write it like this, 7 happens to be 3 plus 2 plus 2. So I've got all the numbers from my first or from my second term of the sequence plus an additional one for this term. Term 4, I have a 9, which happens to be 3 plus 2 plus 2 plus another 2. So again, you'll note all of the numbers from the previous term are represented, and there's an extra one. Now I think I've got enough here to generate a bit of a formula, because this particular line, this is 3 plus 1, 2, 3, 3 2s. This line here is 3 plus 2 2s. And this line is 3 plus 1, 2, and this line is 3 plus 0 2s. All right. So if I write them out sort of this way, trying to figure out the jump each time, and then counting how many jumps I've got, I start to get a pattern showing up like this. Now I want to replace these numbers with some symbols so that I can apply it to any sequence, not just this one. So I'm going to look for the number 3 here. What was number 3? Well, it was the first term in your sequence. So I'm going to give that a special name. I'm going to use A. A is the first letter of the alphabet, so it might as well be the first letter of our sequence. The first term. Okay, so my formula over here will be A plus. Now the next number that shows up over and over again is this 2. So what was 2 in this sequence? Well, if you go from one term to the next, you had to add 2 to get there. And then you had to add 2. And then you had to add 2. So that's the difference between each term in the sequence. So I'm going to give that a letter. I'm going to use a D for difference. difference between each term. All right, so if I replace that, I get a D here. Now, the last thing to sort of figure out here is these numbers 0, 1, 2, 3. Well, it's just going up by 1. So the next term would be 3 plus 4 twos, and then 3 plus 5 twos, 3 plus 6 twos. So I need a structure in this equation that shows me that number. Now, if I look at the terms, I have numbers showing up here as well, 1, 2, 3, 4, and they're going up in a sequence as well, 1, then 2, then 3, then 4, then 5, with no gaps. And if you notice, this number here and this number here, this one is always 1 less than that. So if this is 2, this is 1. If this is 3, that's 2. If this is 4, this is 3. So whatever number I've got here in the subscript, this is always 1 less. So there I go. I replaced all the numbers from this example with letters. So I have an equation now that I can use. So that has given me the general term of an arithmetic sequence. I'm going to try and not write it on my face here. It's the first term plus some number of the difference. Okay, now just while we're at it, this particular word, arithmetic, all that's telling you is that to get from this term to this term to this term, you're either adding or subtracting some number. There is a second type of sequence that we're going to do called a geometric sequence, where you multiply by a number. So if this was geometric, I wouldn't be adding 2, I would be multiplying by 2. So it would go 3, 6, 12, 24, 48. We'll get to those. But for now, we're doing this for sequences where the numbers are just having something added to them each time. So I'm going to clear this off here and see if our formula can be used to solve these little problems here. So for part A, I want the 356th term. Well, 356 will be the n value. So n equals 356. So the 356th term will be my a value, which was 3, plus 356 subtract 1, multiplied by the difference between each term, which was 2 in this example. So I have all the numbers filled in, so I should be able to just work this out. T356 is 3 plus 355 multiplied by 2. T356 is 3 plus 710, which is 713. So if you were to write out all of the odd numbers starting from 3 and went on as far as you liked, by the time you wrote the 713th number in that sequence, you would have hit, nope, that's wrong. If you wrote out to 356 of those numbers, the number you'd be writing was 713. Yes, okay, good. Question B, what term is 25,371? Well, that's not an n value, that's the value of some term. So I have to leave this n in generic because I don't know what it is. I know this is a term in the sequence, I just don't know which one. So I go back to this formula here. I have my a value, which was 3, The n I don't know. The d value was 2. So from an algebra point of view, first thing I would do is subtract 1, then I'd multiply by 2, then I'd add 3. So I have to get rid of this add 3 first. Would give me 25,368. And I'm going to have to divide both sides by 2. Oh Lord, it's a 4 and a 3, half of 3 is, that's not going to work. I'm just going to get my calculator because that's going to save a lot of stress. 25368 divided by 2 gives me 12,684. And the last thing to do is to add 1. So if you started at 3 and wrote out all of the odd numbers, you would have had to have written 12,685 numbers before you finally reached 25,371 in that sequence. So now that we've got this, you can use it to answer all sorts of questions about sequence and series. So I'm going to clean this off and get a new sequence, and we'll try a different type of question. So I've been given 2 terms in the sequence. The 6th term is 25 and the 10th term is 13. And I've been told it's an arithmetic sequence, which gives me permission to use this particular model. Determine the value of term 15. Okay, so I'm going to start filling stuff in to here. So I have term 6 is 25. So that will equal A. That's my first term in the sequence, which I don't know yet, plus n minus 1. Well, I know that n is 6. Multiplied by the difference between each term. Well, I don't know that either. If you were to take a minute, you could probably puzzle it out, but I'm just going to leave it like this for a minute. That means that term 6 is 25 plus A, nope, 25 equals A plus 5D. If I do the same thing for term 10, term 10 is 13, which should be A, my first term in the sequence, which I don't know, plus 10 minus 1 multiplied by the difference, which again I don't know. That leaves me with term 6, or term 10, sorry, being 13 equals A plus 9D. All right. Aggravating. Both of these equations have 2 variables in them, which means I can't actually solve them on their own, but I can solve them by mashing them together using substitution or elimination method that you thought about in grade 10. So I'm just going to get this line out of the way so I can see exactly what I'm working with. I don't need to remember that those came from term 6 and term 10. All I need is this much. If I were to take this equation and subtract that equation, I would end up with A subtract A, which would give me nothing, and the A's would be eliminated. That would leave an equation with just the D value in it, and then I could solve from there. So I'm going to do that. Take the top equation and subtract the second one. So 25 subtract 13 is 12. A subtract A is gone. 5 of these subtract 9 of those is negative 4d. And all I've got to do there is to divide both sides by negative 4. And I end up with negative 3 is the change between each term. Well, that's good. I can take this now and I can feed it to either this equation or this equation to get the a value. I like the top one just because it's there. So 25, I'm not going to have room to do it there. 25 equals a plus 5 times your d value, which is negative 3. 5 multiplied by negative 3 is negative 15. And I'm going to add 15 to both sides, which gives me 40 for my a value. So when I started, I didn't know what the first term was. Now I do. I didn't know how much it was jumping each time. Now I do. So I have all the information I need to fill into this little model to figure out what the value of term 15 is. So term 15 would be a, which I just figured out was 40. 15 is the end value. And the d value is negative 3, which I just figured out. So I have 40. 15 subtract 1 is 14. 14 times 3 is 42, and a positive times a negative is a negative, equals negative 2. So I started with a sequence in the first example, and I was able to analyze it because I could see the numbers. But in this example, I didn't see the whole sequence. I only got 2 snapshots from it. But that was enough to be able to deduce the initial place and how it jumps each time. And then I could use that to find any other term in the sequence. So now that you have that information, you could write out the whole sequence just to fact check yourself. So my first term would be 40. And I'm supposed to drop by 3 each time. So that would be 37, 34, 31, 28, 25. Well, there's my 6th term. 1, 2, 3, 4, 5, 6. 22, 19, 16, 13. There's my 10th sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right where it should be. Then 10, 7, 4, 1, negative 2, which is that last term I was asked to find in the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15th spot, right where it should be. So 2 types of problems, one where you're given the sequence and you have to get the a and the d value from there, or a type of problem where you're given 2 terms and you have to figure out the a and d that way in order to generate some random term.